The first two lines of Sonnet 17 are, "Who will believe my verse in time to come if it were filled with your most high deserts?" What was the most high building in the world during the Renaissance? In fact, for the prior 4,000 years at least? The Great Pyramid, of course. And where was it? Well, in the largest desert known to man at that time, the Sahara. It continues, "Though yet heaven knows it is but as a tomb." The Great Pyramid was thought to be, and still is today by most, a tomb for the pharaoh Khufu, but Shakespeare seems to be hinting that its true purpose is hidden and shows not half of what we assume it to be. In lines 11 and 12, he continues, "And your true rights be termed a poet's rage." True is a mason's term meaning to make level or square 90 degrees. A right angle is, of course, precisely that, 90 degrees. Now think of right angles, and most of us can't help but think of Pythagoras. Here's a 14th century woodcut. Note the spelling of his name in Greek, Pythagora or Pythagoras. The Greek letter upsilon, second letter in the word, is actually pronounced e or u. And indeed, he's telling us that in A Poet's Rage, Pythagoras. And stretched mitre of an antique song. Now, this is always emended in future versions of the sonnets after the original to stretched meter. They say, well, the printer made a mistake. No, he didn't make a mistake. This was very deliberate. Mitre. Stretched alludes to the derivation of the word hypotenuse, the side opposite the right angle of a triangle. It comes from the ancient Greek hypo, meaning under, and teno, meaning I stretch. Stretch under is hypotenuse. Mitre is another mason's term for a joint, usually of two 45-degree angles that form a true right-angled corner, 90 degrees. Antique dates from the early 16th century, when it meant exclusively pertaining to the ancient Greek arts or sciences. And song, well, Pythagoras discovered his mathematical relationships by stretching strings with weights and tuning them. He proved music and math are inescapably interrelated. Okay, now for the actual math. Can you judge a book by its cover? Look at the punctuation. Connect the dots. Notice how this line runs precisely alongside this letter T, like a T square for measuring right angles, yes? Guiding us to that upper dot and completing a perfect right angle triangle. Let's try another one. Starting at this dot after Aspley. Common hypotenuse down to the G, another right angle triangle. You see, this time a perfect 3, 4, 5 triangle. Pythagoras, famous for 3 squared plus 4 squared equals 5 squared. Pythagorean theory. Let's connect through this dot here. See where this line leads us. Points precisely to the end of this seemingly random line. The two lines are usually for containing the author's name, and these are empty, leaving many to speculate a conspiracy concerning the true author, because there's no name there. And when we again connect to the letter G, the dot by the G, same thing. Another perfect right angle triangle with again the same hypotenuse. Let's look at the other line. Same thing again. Incredible. 4 perfect right-angled triangles with a common hypotenuse. Stretch it. And if we now connect through this other dotted T here to the center of that line, the hypotenuse, we find a perfect circle. What's going on here? This is a visual representation of Thales' theorem, which proves that in a circle with diameter AC, any point B anywhere on the circumference forms a right-angle triangle with hypotenuse AC. Thales' theorem is a very important mathematical moment, the first ever documented geometrical proof by the man dubbed the father of science and Greece's first philosopher. Born circa 624 BC, he's said to be Pythagoras' mentor, the man who told him to travel to Egypt and seek out their ancient wisdom. But Thales was famous for something else. He was the first person to measure the height of the Great Pyramid. Now, to do it, he must have calculated the slope angle of the pyramid, yet he does not record it, and we have no record of this measurement until about 200 years after the sonnets were published. So what else do we have here? Because these are radii of equal length and equal angles, this is an isosceles triangle. And so is this, and this, and this, and this, 5 of them. Now if we skip one point here at the bottom, we have another 4 of them. And if we skip 2 points here, we have another 3, and finally we have another 2. Altogether, 14 perfect isosceles triangles, all radiating out from this one central point of this circle. And if we measure the angles of these triangles, add them all up, and divide by 14 to get the average, it comes out to be 51.635 degrees. Now we know today the angle to be 51.843. That means that this is about 99.6% accurate. But this is by no means the whole of the story. The mathematics is just a little bit more complicated. You've already seen from other videos that the points on the circle give us these various math constants. The reason that that's even possible is that the size of these dots at G and imprinted are much, much bigger than the other dots here. And there's a reason for that. It's simply geometrically impossible to do what John Dee has done here without making those dots bigger, so that the hypotenuses of each of these triangles vary ever so slightly from each other. And therefore the angles of the hypotenuses are minutely different from each other, and thus the angles of the isosceles triangles that are formed are going to be affected by that tiny, tiny difference in the hypotenuses. It amounts to about 1/4 of a degree to maybe 1/2 a degree. Well, summed to the previous sum, that means this is going to go minutely up, and therefore closer to the actual Great Pyramid angle. But honestly, at this point, I think it's superfluous to say that that's an intentionality. It's probably far more reasonable to assume that this is just inherent in the beauty of the overall mathematics that John Dee is pointing out to us here. For those of you who want to go deeper into it, I would encourage you to go to the website, and there's a section under Sonnets called Math. It deals expressly with exactly how deep this goes, and to your heart's content you can check all the numbers there to find out precisely why John Dee made these dots just the right amount larger so that the geometry would work out. So in conclusion, seeing that these precise measurements of lines and angles are all hidden within the punctuation of the dots, I had been wrestling with one maddening clue for a couple of years. Why had the author put dots after certain numbers of sonnets? To be specific, Sonnet 9, echoed precisely in the cover here, 9 with a dot after it. Sonnet 9, the number 9, has a dot after it. Sonnet 18 has a dot after it, and Sonnet 122 has a dot after it. All the other 154 sonnets have no dots after their numbers. Now, 9 made sense. It marked the very center of the procreation sonnets 17 base, so makes sense, it was structural. 18 made sense as the start of a new level in the pyramid structure, but 122, I just couldn't see it. I didn't know what it represented. Finally gave up, and of course when you give up, that's when the mind is really primed and ready to just receive the answer. I knew there had to be something I was missing, and I was given it in a rare lucid dream. I saw the letters immediately next to each of the punctuation dots. All these dots are next to certain letters. They formed themselves into the word Egypt, and with a 9 and a T left over, which then slid into the right angle of one of the triangles. It was almost cartoonishly comical. 90 degrees, of course. Suddenly it was crystal clear. This was a key to deciphering the entire thing. True rights, true 90 degrees, a poet's rage, Pythagoras, of course we all know the Pythagorean theorem, stretched mitre, stretched angle. The 9.t was clearly referring to the 9-dot sonnet, so I knew I was looking for 90 degrees emanating from the middle of the 17 base, and obviously a straight vertical takes you to the apex, and a pure 90-degree angle. But it doesn't accommodate the other two numbers. And aligning with number 18 makes it clear that we're wide of the mark for 122. What to do? Well, I just did what I'd seen in the dream, and I started to stretch the angle by squashing the height of the pyramid. Clearly there's a point where the angle becomes a perfect 90. And after that you've gone too far, and it's simplicity itself. You just stretch it back. There's one point, and one point only, where the angle created by the numbers 9, 18, 122 is a right angle. And that means there's one height, and one height only, at which this works. The bard is telling us any old triangle is not good enough. He's precisely chosen these numbers and locking in their position at the very point where they produce 90 degrees, locks in the side slope angle also, which happens to be 52.2 degrees. I'll be filling you in on the significance of that in another post.